Hello guys, how are you today? So today I'm gonna be explaining chapter 1 of mechanics, which is about one-dimensional motion. We'll get started with the first question. By the way, we only have from 1.1 until 1.12, so 1.13, 1.14, I'm not doing them. You don't have to do them. We only have from 1.2 until 1.12, okay? So section 1.2, displacement versus distance. Consider the following quantities. Which of the given quantities is scalar? What do they mean by a scalar quantity? When they say a scalar quantity, they mean something that does not have a direction. Only a magnitude doesn't have direction. Only what? Only a magnitude. So we look at all of them and we see velocity. Velocity can be positive and negative, meaning it has a direction. Force, you can say, oh, the force goes north, south, east, west, like it's at an angle. It does have a direction, so I'm gonna say theta because it can have an angle. So it does have a direction. Mass, you cannot say, oh, my mass is negative 15. You can't have a negative mass. That means it's only positive. If it's only positive, that means it does not have a direction and that it's only a magnitude. So for sure, rho c would fit in the scalar quantities. And then last but not least, displacement. You can, like when you're looking at displacement, especially on a graph, you can go backwards and forwards and backwards and forwards, right? And you'll be adding and subtracting and adding and subtracting. But if you're looking at it in a distance point of view, you would add all of the times she traveled, or like the object traveled. So displacement, I'm gonna say it can be positive, negative. That means it's what? It's a vector quantity. So what's not a vector quantity? Which of the following is a scalar quantity? It is what? It is mass. We move on to question number 2. What does it say? It says a toy car initially at point A, which is 5 meters to the right of the origin, moves along a straight line towards the right and reaches point B 12 meters away from the origin. The toy car is then turned around and then moves through 1 meter. I always like to draw what happened, right? I would say that a toy car initially at point A, right? So point A is 5 meters to the right of the origin. So I'm gonna put my origin over here. It moves along a straight line towards the right and reaches point B 12 meters away from the origin. So it moves until it reaches point B, which is how much? Which is 12 meters away from the origin. Then the car is turned around and moves through 1 meter. What does this mean? This means it will turn around and go to point C, which is how much? Which is 12 minus 1, which is 11 meters. Now, they want the total distance traveled by the car. Perfect. First of all, the car. The car moves from the origin all the way to point A. So this is already what? 5 meters. Then it moves from point A to point B. Now, does it travel? Oh, my bad. Wait. You see, it's very important to read. I fell into a trick. If I didn't read, I wouldn't have noticed. Initially at point A. What does this mean? This means the car starts at point A and then it goes to point B. Okay, if it starts at point A and it's 5 meters to point B, which is 12 meters, how much does it travel? It will travel 7 meters. So we have so far 7 meters. Then from B to C, how much does it travel? It travels 1 meter. So 7 meters plus 1 meter, that's gonna be 8 meters. Now notice, in distance is a scalar quantity. It will not have a direction. That means whatever answer you get, you have to put it in what? You have to put it in absolute value. Okay, that's it for the distance. Let's now talk about the displacement. What does it say in the displacement? What's the net displacement of the car? There's a very simple way to find the net displacement. You take the initial point where it started and the final point where it is stops, okay? So from here to here, how much does it travel? From 5 to 11 meters, it would travel 6 meters. So very simply, the displacement of the car is what? The displacement of the car is 6 meters. Perfect. We finished question number 2. We'll move on to question number 3. What does it say in question number 3? The box shown in the diagram below moves uniformly, covering a distance of 5 meters every 2 seconds. What is the speed of the box? Okay, we know that speed is what? Is the distance over the time, right? Now, they told us it covers the distance of 5 meters every 2 seconds. So 5 over 2 meters over second, you will get 2.5 meters per second. This is the speed of the box. Now, what is the velocity of the box? Now, this is very important because box moves in a straight line in one direction. Okay, what can we say here? We can say that displacement is equal to what? Is equal to the distance. The only scenario where displacement and distance are equal is if the object moves in a straight line in one direction. So in this scenario, velocity is going to be displacement, which is 5 over time. So you're going to get 2.5 meters per second, but don't forget there is a direction. They gave us the compass over here, north, east, south, west, right? And as you can see, the box is going eastwards. That means it's 2.5 meters per second due east. Perfect. We'll move on to question number 4. What does it say in question number 4? A particle covers a distance of 120 meters at an average speed of 15 meters per second, then an additional distance of 200 meters at an average speed of 10 meters per second. What is the total average speed of the particle? How do we find the total average speed of the particle? Very simply, what we'll need to find is the total time. When we find the total time, we will also find the total distance. And then what do? You do total distance over total time, and you'll get the total average speed, okay? So let us find the total time. How do we find it? First of all, we find time of this part of motion plus time of this part of motion. So it covers a distance of 120 meters at an average speed of 15 meters per second. Time is distance over speed, so it's gonna be 120 meters over 15 plus an additional distance of 200 meters at an average speed of 10 meters per second plus 200 meters over 10 meters per second. Put it on the calculator. 120 over 15 plus 200 over 10. This would give me the total time to be how much? To be 28 seconds. Now the total distance traveled is 120 plus 200, which is how much? Which is 320 meters, right? So what would be the total average speed? It would be the total distance, 320 divided by the total time, 28. So 320 divided by 28, and this would give me an answer of 11.4 seconds. Okay, we'll move on now to question number 5. A boat traveling along a straight line starts its motion at 12 p.m. and moves for half an hour at an average speed of 60 kilometers per hour. At 12:30 p.m., the boat changes its speed to cover 70 kilometers in an additional half an hour. What's the total distance covered during the journey? So in the first half of the motion, they did not give us the distance, but in the second half, they told us it travels another 70 kilometers. So we know that the second half of the motion is how much? Is 70 kilometers in distance. Plus now we'll need to find what? We'll need to find the distance of the first part. We know distance is equal to speed times time. I'm getting all of them from what? One simple equation, which is distance over time is equal to speed. Then you mix and match and you change and I don't know what until you get what? Until you get the equation that is suitable for your scenario. So my speed now is 60 kilometers per hour. And then it says it moves for what? It moves for half an hour. How much is half an hour? Basically half an hour, 1 over 2. So 60 times 1 over 2 will give me what? Will give me 30 kilometers. That means how much was the distance that he traveled? He traveled 30 kilometers. Perfect. So 30 kilometers plus 70 kilometers will give me the total distance, which is how much? Which is 100 kilometers. Part B, what does it say? What is the average speed of the boat between 12 p.m. and 1 p.m.? Okay, how do we find the average speed? We have the total distance, which is what? Which is 100 kilometers, divided by the total time. He took half an hour here and half an hour here. So half an hour plus half an hour, it will be 1 hour. So it will give me 100 kilometers per hour, okay? So that's it for question number 5. We'll move on to question number 6. What does it say? The position time graph of two toy cars A and B is shown below. Calculate the average velocity of each car in the first 8 seconds. How do we calculate the average velocity in the first 8 seconds? You just come here, right? They give you the position and then they give you so what did they give you? They give you the position and they give you the time. So we will be able to find what? We'll be able to find the average velocity, okay? The average velocity is displacement over time, right? So what do? I take for car A the final position, initial position. So it's gonna be final position minus initial position. So it's gonna be 4 minus 8 over the total time traveled, which is how much? Which is 8 seconds. So you'll get what? Minus 0.5 meters per second. Now, for car B, again, it's gonna be final position minus initial position. So it's gonna be minus 2 minus 10. I think I put the brackets wrong. Minus 10 over what? Over the final time, which is what? Which is also 8 seconds. So it's gonna give me what? It's gonna give me plus 1 meters per second. Okay, perfect. Now, part B. Assume the cars continue to move uniformly. Explain how to determine if the cars ever meet. Well, very simply, what you could do is you could extend the graph. The more you extend the graph, you will see they will come closer to each other until they meet at what? Until they meet at a certain point. Now, calculate the time that the cars meet. Let us see. Since we cannot expand, let's say we cannot expand and will not get an accurate answer, instead of expanding the graph, we will need to solve it. What is the equation of the position of car A and the equation of the position of car B? Why am I asking? First of all, and most importantly, logically speaking, if two cars meet, they have to be at the same position. One cannot be 50 meters away from the other. That will not make sense. How do they meet? No. In order for them to meet, they should have the same position and they will have what? They will have the same time as well. So what's the equation of motion? We found the slope, which is the velocity for car A, it's minus 0.5. So it's gonna be minus 0.5t plus x initial, which is 8, is equal to delta x, or like is equal to x. And then for B, it was t, 1 times t, plus minus 10 is equal to what? Is equal to x final. Now, first of all, we know that they have what? They have the same position and they have the same time, right? So, what does this mean? This means if they have the same position, then I can substitute it, right? So now I can say t plus minus 10 or t minus 10 is equal to minus 0.5t plus 8. Then I could move this here and I could move that there. I would get 1.5t is equal to how much? Is equal to 18. And then what could I do? I could do time is equal to 18 over 1.5 and I would get my answer, which is how much? Which is 12 seconds. If you open the answer key, they expanded the graph, they extended the lines, and they got the point of intersection to be how much? To be 12 seconds. And we got it only by a system of equations. Part 3. Determine which car has covered a greater distance by the time they meet. Justify your answer. Okay, so here it's more about looking at it initially. They will both meet at the same time, right? So instead of comparing like how much distance they travel during this time, you can compare this already same time that's given to us in the graph. Here, car A, how much did it travel? As in distance, car A traveled 4 meters because it went from 8 all the way till where? Till 4. So it travels what? It travels 4 meters. Then for B, B travels 8 meters. Now which is larger, 4 or 8? For sure, 8 is larger. That means for all scenarios, car B is always gonna travel the greater distance. So what did they do in the answer key? They took the 12 seconds, they found the distance traveled from 0 to 12 seconds, and then they compared them. Instead of doing this and wasting your time and blah blah blah, just go back to the graph. See, they already gave you at the same time how much they traveled, and compare. You see car B travels more, that means for sure car B is always gonna travel more. Now, That's it for question part 3. We'll move on to 1.6, question 7. What does it say? The graph below shows the variation of the displacement of a cyclist with time. What is the velocity of the cyclist at time 4 seconds? So at 4 seconds, they want what? They want the velocity of the cyclist. We're dealing with a position time graph. If it's not x or s or whatever, just check the unit. Meters, seconds, so it's a position time graph. Now, as you can see, we have a straight line, right? So what does it mean if we have a straight line? That means wherever we put a point on this straight line, it's gonna have what? It's gonna have the same slope. That means all throughout the line, we have what? We have the same slope. So what is the slope of a position time graph? The slope of a position time graph is velocity or speed. Now, in some cases, it's both velocity and speed. Some other cases, it's not velocity and speed. We need to ensure, first of all, that it's traveling in one direction and in a straight line. Then you can ensure that the slope of a position time graph is the velocity and the speed. Okay? So basically, I spent, I think, like around 1 minute explaining random things just to come to the conclusion that if we want to find the velocity of the cyclist at a specific time t, what does this mean? This means they want the instantaneous velocity, right? They want the instantaneous velocity. That means we need to find the slope of this straight line. So now we can just choose any random 2 points. I can take this point over here, and then I can take this point as well over here. So I'll have what? I'll have 24. No, sorry, what are my points? My first point is 0, 24. My second point is 6, 8. Now you do y minus y over x minus x. 24 minus 8 over 0 minus 6 will give me my answer, which is what? Which is minus 2.7 meters per second. Okay, so that is it for question 7. Grid, we'll move on to question 8. What does it say in question 8? The diagram below shows the change in the position of a swimmer in a freestyle swimming competition as a function of time. She covers the length of a pool within 33 seconds, rests for 1 second, and then swims back to her starting point in 26 seconds. At which point is the swimmer at rest? Whenever the swimmer is at rest in a position time graph, that means she's having a what? She's having a constant position, right? And whenever she's having a constant position, velocity is equal to 0. And when velocity is equal to 0, that means it's what? It has a horizontal slope. So we need to find the point that has a horizontal slope. For sure it's D, because if you draw D, it's going to have what? It's going to have a horizontal slope. And it's going to have what? It's going to have basically a slope of 0. That means velocity is 0, because in the xt graph, velocity is the slope. So that means she's staying in a constant position, and that means our answer is what? Our answer is D. We'll move on to part B. In which time interval is her velocity constant and negative? So, looking at my graph, here it's constant, but it's positive because my slope is increasing. Here it's not constant, it's curved. Here it's also curved. At D it's a 0 velocity. And then from this time over here, which I'm going to assume is 34 seconds, till 60 seconds, we have a constant straight line. That's decreasing. That means it's a constant velocity and it's negative. At which time intervals? At the time intervals 34 seconds and 60 seconds. Now, they said, what is the average velocity of the swimmer in the interval 15 seconds, 33 seconds? 15 seconds is at B. 33 seconds is until D. So they want what? The average velocity. In my opinion, look what we would do. We would draw a straight line and we would find the slope of this straight line. Now we need to take the position at B. At B15, the position is 10. At D33, the position is 40. So now we have the values of our y and our x. We can find the average velocity. We're going to do y minus y over x minus x. So 40 minus 10 over 33 minus 15, and then I would get an answer of 1.67 meters per second. So this is the average velocity of the swimmer. We'll move on to section 1.7, question 9 grid. When a car moves from an asphalt road into a rough dirt patch, its speed decreases. Whenever speed decreases or increases, what do we have? We have acceleration. From 20 meters per second to 12 meters per second in 2 seconds. What's the average acceleration of this car? So what do you need to do? You need to do velocity final minus velocity initial over time, because average acceleration is the change in velocity over time. So 12 v final minus v initial 20 over 2. This would give me my answer to be minus 4 meters per second squared. I think that's it for 1.7. We'll move now to 1.8, which is the velocity time graphs. Question number 10 grid. The diagram below shows the variation of a subway train's velocity with time. What is the acceleration of the train at time 30 seconds? They ask you for the acceleration at a specific time. That means they're asking for the instantaneous acceleration. Now, what about this instantaneous acceleration? I will find it over here and I will see, okay, there is a straight line. Whenever I have a straight line, then I directly find the slope. If I don't have a straight line, what do? I put a tangent. So let me find the slope of this. So I have the point 60, 21, and 0, 0. So what would be my my acceleration? It would be 1 minus y, which is 21 minus 0, over x minus x, which is 60 minus 0. And it would give me my average acceleration to be 0.35 meters per second squared. Part B. In what time interval is the magnitude of the acceleration of the train greatest? Well, very simply, what you need to know whenever they ask about magnitude of acceleration in a velocity time graph or magnitude of velocity in a position time graph, then they are talking about the slope. And usually the greatest slope is the steepest. Okay? So I look at my graph and I see which of them is the steeper slope. What does it mean, the steeper slope? That means if I'm comparing this slope to this slope, logically speaking, this slope is what this slope is steeper. Okay? And because the slope is steeper, that means it's gonna have what? It's gonna have a greater value of what? Of the magnitude of acceleration. So for sure it's gonna happen between what? Between 90 and 120 seconds. We'll move on to question number 11. What does it say in question number 11? In the diagram below, it shows the variation of a cyclist's velocity with time. Explain how to calculate the instantaneous acceleration of the cyclist at time 10 seconds. So they didn't want us to calculate it, they wanted us to explain. So what do? They want instantaneous acceleration at time 10 seconds. So I will come time 10 seconds here. So what do I do in this scenario? I will need to draw a tangent. So I draw a line tangent to the VT curve at time 10 seconds. Or it's kind of like this. Yeah. This is my line tangent to the VT curve. And then what did they say? So I'm going to extend it a bit until I reach here. They said, draw a right triangle. So they're telling me to continue this by drawing what? By drawing a right triangle. So this is my right triangle. And they said you have your hypotenuse over here. How do you find the value of the hypotenuse? It's gonna be the rise over what? Over the run. So this is one way to solve it. And in my opinion, it's kind of the best way to solve it. We'll move on to question number 12. What does it say in question number 12? The velocity time graph of a particle is shown below. Calculate the average acceleration of the particle between time 2 seconds and 5 seconds. They gave me 2 times and they want what? The average acceleration. So now I will draw a secant. How do I draw the secant? I draw the secant from my time 2 seconds and my time 5 seconds. I will draw a straight line passing through both of them, right? And then what do? Then I choose my point over here. So it's 5.25 and my point over here, which is 5.4. 2.4. Now what do? We do y minus y over x minus x. We find the value of the slope. So 25 minus 4 over 5 minus 2 will give me my answer, which is 7 meters per second squared. Part 13. Why is the velocity time graph of a body moving in UARM linear? First of all, what does UARM means? It means uniform accelerated rectilinear motion, meaning we have a constant acceleration. If we have a constant acceleration, that means our slope is what? Our slope is constant. If our slope is constant, that means it's gonna be a line, so our acceleration is gonna be linear. Now, we'll move on to question 14. Does a positive acceleration always mean that a body is speeding up? No, not necessarily. What does a positive acceleration mean? And how do we define speeding up and slowing down? Speeding up depends on what? Depends on two factors, the velocity and the acceleration. So let us take a couple of cases. I'm going to have my velocities here and my accelerations here. I have a positive velocity, positive acceleration, a negative velocity, a negative acceleration, a positive velocity, a negative acceleration, a negative velocity, and a positive acceleration. So if I multiply my velocity and my acceleration, what am I gonna get? Here I'm gonna get a positive answer, a negative answer, and a negative answer. Here is where I determine if it's speeding up or slowing down. If both my acceleration and velocity are positive, I'm speeding up. If both my velocity and acceleration are negative, I'm speeding up. If one is positive, one is negative, I'm slowing down. So no, a positive acceleration does not always mean that a body is speeding up. It only speeds up a positive velocity, right? And then you can just explain that if I have a negative velocity and a positive acceleration, it's gonna slow down. We move on to question number 15. Consider the velocity time graph below of the particle. The instantaneous acceleration of the particle at time 5 is a5, and its acceleration at time 7 is a7. Compare the magnitudes of these values at time 5 and at time 7. So they don't want us to solve it, and instead of wasting time and finding the velocity of I don't know what and whatever, instead of wasting our time, what we could do is we could look at these slopes. Here, look at this slope and look at this slope. This is the steeper slope. That means what? That means it has a greater acceleration. Now, please, they said compare the magnitudes. If they did not say compare the magnitudes, this, you would find it to be more negative than what? Than this. So which would be bigger? This one would be bigger, but because they said magnitudes, you would put this and this in absolute value. You will see that this value is greater, so acceleration 7 is greater than acceleration 5. We'll now move on to question 1.9, motion with a constant velocity. So section 1.9, question 16. At 1 p.m., a car is spotted traveling at a constant velocity of 25 meters per second towards a street sign 2,000 meters away. Determine the equation of motion of the car. Okay, so they told me that my velocity is what? My velocity is positive. And they said that I'm going towards a street sign 2,000 meters away. What does this mean? This means from where I am, the street sign is minus 2,000. Or no, not like that. Like, for example, let us draw and imagine what's happening. We have a car over here, and then we have a street sign, which is 2,000 meters away. I'm moving at a velocity of 25 meters per second, and it's positive. So if I took this to be my initial velocity, my initial position, x initial, how much would this be? From where I am over here, this would be what? This would be minus 2,000 meters, right? Because if this is my x initial and my origin, let us say, okay, and I am behind it, to the left of it, that means my position is minus 2,000 meters away from it. Right, so what would be the equation of motion? Equation of motion is what? Is ax plus b. This is the slope equation, but it also works. Because do you know, like, the equation of motion of a car with a constant velocity? It's what? It's x final is equal to x initial plus velocity times time. Very simply, ax plus b. So my velocity is what? My velocity is 25 meters per second times time. I don't know what my time is. But I know my x initial is how much? My x initial is minus 2,000. Okay, so x final minus 2000 plus 25 times time, or 25t minus 2000. This also works. Now we move on to 1.10, which is displacement as the area under the VT graph, question 17. What does it say in section 1.10? 17 grid. The diagram below shows the variation of a cyclist's velocity with time. Okay, this is a velocity time graph. They want the displacement. Displacement over time is equal to velocity. Displacement is equal to velocity times time. What if I have a graph? If I have a graph, then it is what? It is the area. So I just need to find the area. This is a trapezoid. So base 1 plus base 2 times the height over 2. So how much is this? It's from 5 till 15, which is 10, plus 20 times the height, which is 6 over 2. So 10 plus 20 times 6 over 2. This would give me my answer to be my bad, to be how much? To be 90 meters. Perfect. We move on to section 1.1. So 18, 19, 20, 21. And then free fall 22, 23, 24. And then we finish. Good job. So we reached motion with a constant acceleration, 18 grid. A toy car is initially moving in the positive direction at 0.50 meters per second. At time 0, the car accelerates at 0.20 meters per second for 6 seconds. What's the displacement of the car? They told me displacement, delta x. They gave me time. They gave me acceleration. I don't take this time because this is time initial and this is time final. So time final minus time initial is how much? Is 6. So I'm going to say time final, time initial, right? And then what do I have here? I have my velocity initial. Okay, so what equation can I... Excuse me. You guys should have some certain equations memorized. If you don't have them memorized, this whole section 1.11 is not gonna work out. You need to have them memorized, or not even memorized, it's just like understand them in general. What did I find? I found delta x, t final minus t initial. I will get time, t final minus t initial, 6 minus 0, which is 6 seconds. Okay, I have my acceleration and I have v initial. How can I find the displacement? Delta x equal 1 over 2 at squared plus v0 t. Okay, so it's gonna be 1 over 2 times the acceleration. What's my acceleration? 0.2 times the time, which is 6 squared, plus v initial, which is 0.5 times the time, which is 6. Put it on the calculator. 1 over 2 times 0.2 times 6 squared plus 0.5 times 6. I get my answer to be 6.6 meters. So this is my displacement. I'll move on to question number 19. The position of a particle moving along the x-axis is given by this equation over here. Determine the characteristics of the motion of the particle. This is x, right? If there's no initial position over here, because here usually it's what? It's x final equal whatever plus x initial. If there's no x initial, that means x initial is at the origin, right? And if x initial is at the origin, that means that this x is also equal to what? It's also equal to delta x. Delta x equal 1 over 2 at squared plus v0t, right? Now, I have minus 2t squared. What does this mean? This means that minus 2t squared is equal to half a t squared. I can cancel t squared and t squared. Minus 2 equals half of a. A is equal to minus 4. What does this mean? This means my acceleration is minus 4 meters per second squared. Then, what do I have? I have 3t, v0t. That means v0 for me is equal to how much? It's equal to 3. That's it for part A. Part B, what does it say? Determine the velocity of the particle at 3 seconds. Perfect. How can I determine the instantaneous velocity if they gave me the equation of position or displacement? If they're talking about instantaneous at a specific time, very important, okay, you will take the derivative, right? So this would be then 3 minus 4t. So at 3 seconds, 3 minus 4 times 3. So minus 9 meters per second. Now, very important. Average velocity. Average velocity between time 2 seconds and time 6 seconds. Here we don't take the derivative. Instead, what do? We find the displacement at 6 seconds and then the position at 6 seconds and the position at 2 seconds. And then we do change in like the displacement over the time. Okay? So 6 seconds. What will my position be at 6 seconds? I will substitute it here. I would get my position at 6 seconds to be minus 54, right? So here, x is equal to minus 54. At time being 2 seconds, I would substitute it over here. I would get it to be x is equal to minus 2 meters, okay? Now, how do I find the average velocity? It's gonna be change in position over time. So minus 54 minus 2 over what? Over 6 minus 2. So minus 52 over 4. What will I get as an answer? I will get minus 13 meters per second as my answer. Move on to question number 20. A car is moving at a constant speed of 30 meters per second along a horizontal. So a car is moving at a constant speed of 30 meters per second along a horizontal and straight road where the speed limit is 80 kilometers per hour. A police officer on his motorcycle spots the speedy car and starts chasing it. 2 seconds after the car passes him, find the distance covered by the car before it's caught by the police officer. Given that the motorcycle accelerated from rest at 6 meters per second squared, take the origin of time and space at the time and point where the speeding car passes the police officer. Okay, so what we can do now is we can label whatever we have. We have constant speed of the car, so V0 car. Or like, let me just say V car because it's a constant speed. Now, this is very crucial information. The car travels a time t seconds, right? So honestly, this is why I would prefer to graph whatever I have. Okay, so let us graph it. Okay? This is gonna be velocity and this is gonna be time. Now, the velocity of the car is what? Is a constant velocity of 30 meters per second. So it's always 30 meters per second. Then, after 2 seconds, they said take the origin, okay, to be the time where the car passes the police officer. After 2 seconds, he starts what? The police officer starts moving, right? He starts moving until he catches up with what? Until he catches up with the car at a specific position x, and at this specific position x, the time would be how much? The time would have been how much? It would have been t seconds, right? So again, the velocity of the car is a constant velocity. That's why I put it as a flat line. Then, after 2 seconds, the police car starts moving, right? And then he starts accelerating until he will what? He will reach a position, a certain position, delta x, where what? Where for both of them, the car and the motorcycle, the time is t. So I'd like to do this based on what? Based on equations of motion. If I have a constant velocity, right, and I want to find the distance or the displacement it travels here, it's what? It's a rectangle. So it's gonna be side times side. So if my velocity was 30, right, and then the total time taken was t, how much would be the displacement or the distance of the car? It would be 30t. Very important. Now 30t is equal to what? Now 30t should be equal to the area of what? Of the motorcycle, which is the triangle. But I have a missing information, which is how much was the final velocity. Instead, what I could do is, because it's an accelerating car, I can use the equation of motion of acceleration. What's the equation of motion of acceleration? Delta x equal 1 over 2 at squared plus v0t. I can use this. How much was my acceleration here? It was 6. So it would be 1 over 2, 6 times t squared. How much is my time? My time is not t. My time is t minus 2. So t minus 2 squared, and the velocity initial, because he starts from rest and he accelerates 6 meters per second squared. That means v initial is 0 and anything times 0 is 0. So that means it's going to be 3t minus 2 squared. So now what can I do? I can make these two equal to each other. So 30t is equal to 3 times t minus 2 squared, right? Divide both sides by 3, I will get 10t is equal to t minus 2 squared. Let me expand this. 10t will be equal to t squared minus 4t plus 4. Then I move this t to the other side. I will get it to be minus 14t. Now, what do I do now? In order to find the values of t where they meet, I will make this equal to 0. So I'll do mod 5, 3. I'll put 1 minus 14 and 4. And I will get two possible answers. What are they? The first answer is 13.7. And my second answer is 0.29 seconds. Now, can t be 0.29 seconds? Logically speaking, if the motorcycle started accelerating at 2 seconds, how can he meet the car beforehand? Now, speaking like, if you think about it a little bit more, it is true, because what happens, the car passes the police officer, so there's a certain time, which is 0.29 seconds, where both the car and the police officer are at the same position, but this is not the time we need. We need the time where he catches up to the car, which is 13.7 seconds. We'll move on to question 21. A train moving along a straight track accelerates from rest at 2 meters per second squared for 20 seconds. It then moves at a constant speed for 120 seconds. Finally, the train decelerates uniformly to stop in 40 seconds. Okay, so let us graph what they gave us, okay? If we graph what they gave us, they gave me a train moving along a straight track, accelerates from rest, so that because we have acceleration, I will use the velocity time. It accelerates from rest at 2 meters per second squared for how much? For 20 seconds. So how much would my velocity be? My velocity would be acceleration times time, which would be how much? 2 times 20, which is 40 meters per second, okay? Then, what is my second phase of motion? It then moves at a constant speed for 120 seconds, okay? So 20 plus 120, 140 seconds. And then the train decelerates uniformly to a stop in how much? In 40 seconds. Write the equation of motion of the train in each phase. So here what do I have? For this one, I'm going to call this 1, 2, and 3. For 1, what do I have? I have acceleration, 2 meters per second squared. I have time, 20 seconds. And I have v initial, which is from rest, which is how much? Which is 0 meters per second. So how can I find the equation of motion? Delta x is equal to 1 over 2 at squared plus v0 t. v0 is 0, so this goes bye-bye. Then I will have 1 over 2 times 2, which is 1 times t squared, which is how much? Which is 20 squared. So it's going to be what? It's going to be 400. Okay, for the second phase, it's what? It's 120 seconds. And the acceleration is how much? It's 40 meters per second because we found it, right? So what would be the equation of motion? Because it's URM, it's a constant velocity. We can use x final equals x initial plus velocity times time. X initial, now my x final is what we are looking for, right? My x initial is what we found initially. How much was this? This was 400, right? That means over here, he reached 400 meters. That means x initial would be how much? X initial would be 400. So 400 plus the velocity, which is 40 times the time, which is 120 seconds. So you would get it to be 5,200. Don't forget 5,200. Now, for the third phase of motion, what is it? It is UARM, but we need to find the acceleration. How do we find the acceleration? I have velocity initial, 40. I have velocity final. No, my bad. I have velocity final, which is 0, and I have the time, which is plus 40 seconds, 140 plus 40, 180. So 40 seconds difference, right? So I can find the acceleration by doing v final minus v initial over what? Over time. So it's going to be 0 minus 140 over 40 seconds. So it's minus 3.5. My bad, I wrote it wrong. Minus 0 minus 40, right? V final minus V initial over the time. So 0 minus 40 over 40, so that should be minus 1 meter per second squared. So my acceleration here is how much? My acceleration is minus 1 meter per second squared. Now I can find the equation of motion by doing what? By doing 1 over 2 at squared plus v0t plus what? Very important, x initial is equal to x final. Before we were saying delta x equal 1 over 2 at squared plus v0t. Delta x is x final minus x initial. So I will move x initial to the other side now because I want to find x final. So x final is equal to 1 over 2 times 1 times 40 squared plus v0, which is 40 times 40. Sorry, v0, how much is v0? Yeah, 40. Plus x initial, which is how much? Which is 5,200 meters, okay? So what will I get my answer to be? 1 over 2 times 1 times 40 squared plus 40 times 40 plus 5,200. I should get 7,600 meters. Now from all of them, we derived an equation to get x final, right? For the first phase of motion, we got that x final is equal to what? Is equal to my acceleration, which is 1 times what? Times the time squared. For my next phase, which is phase 2, we got the equation of motion to be what? To be x final is equal to velocity. What was my velocity? 40 times my velocity times my time. So it's gonna be time minus 20 seconds, because if you remember in the graph, it was time and then 20 seconds. So time minus 20 seconds plus 400 meters plus x initial basically. And then for phase 3, let me change the color. I would get it to be minus 0.5 times time minus 140 seconds squared plus v initial 40 times time minus 140, so v initial times time, plus x initial, which was how much? Which was 5,200. By the way, I did a calculation mistake in when I was finding the x final in part 3 in the previous one. I got the answer to be 7,600. In fact, no, the answer is only 6,000, not 7,600, okay? So these are the equations of motion. Perfect, we're gonna leave them aside. We'll move on to part B. Find the position of the train at 5 seconds, 60 seconds, and 160 seconds. Do you remember in our graph, what did we have? We had, this was 20 seconds, this was 140 seconds, and this was how much? This was 180 seconds. Now I need to find for each time in which time interval it is. For example, 5 is in time interval 1. 60 is in interval 2. 160 in interval 3. So now I substitute each of the times in the corresponding equation. So here it should be 5. Here it should be 60. And here it should be how much? Here it should be 160. So for the first one, I'm going to get 25 as an answer. For the second one, I'm going to get 2,000 as an answer. And for the final one, I will get how much? I will get 5,800 as an answer. Okay, that's it for 21. Now we reach free fall. We have 3 questions and then we're done. Good job. So, question 22. An object released from rest several meters above the ground moves at a constant acceleration in the absence of air. In the absence of air resistance, what's the numerical value of this acceleration? What you need to know? You need to see velocity initial, if it's going up or if it's going down. So he's on top here, right? And the person will release this object. That means velocity initial is going downwards. Wherever velocity initial is going, what happens? My acceleration, or g, is gonna be what? It's gonna be in the opposite direction. So 9.8 meter per second squared. That means it's what? It's positive. But if, for example, we had a person, right? And this person will shoot the ball up and down. V0 initial was how much? Was positive. It's going upwards, right? That means g everywhere is gonna be negative 9.8 or negative 10. So it always depends on V0. So in this scenario, because he drops the ball from rest, he didn't throw it in a curve, no, he drops the ball from rest. That means V0 is downwards. That means my G is what is positive 9.8 meters per second squared. Now, question 23. Okay, this is a very important question. It's a grid question and it might come in the final. Describe the apparatus used to experimentally determine the acceleration of free fall. What apparatus do we need? We need a steel ball. I think I wrote steel wrong. Steel ball. We need an electromagnet. We need a trapdoor. We need an electronic timer connected to the electromagnet and the trap door. Basically, we also need a ruler, and that's it. Basically, in the exam, they will ask you, describe the apparatus used to experimentally determine the acceleration of free fall. You'll say, okay, I need a steel ball, an electromagnet, a trapdoor, an electronic timer connected to the electromagnet and the trapdoor, and a ruler to measure the distance between the electromagnet and the trapdoor, or the steel ball, is it? No, between the electromagnet and the trapdoor. How will this experiment go? I have a steel ball, and it's connected to what? Connected to the electromagnet, right? Because I turned on the electromagnet and it will attract the steel ball, so it's on the steel ball. Then I will have a trapdoor, which is basically like a surface, right? That will detect the steel ball falling on it. Then I have an electronic timer, or sorry, what does a trapdoor do? Like, the steel ball will fall on it, and then the trapdoor will open, for example. Then I have the electronic timer connected to the electromagnet and the trapdoor. Why? Because as soon as I turn off the electromagnet, what will happen? The timer will turn on, right? The steel ball will fall, and then as soon as the steel ball lands on the trapdoor, and the trapdoor opens and closes, the timer will take the time that it takes, it will measure the time that it takes from dropping from the electromagnet all the way until it reaches where it reaches the trapdoor. And then what do? I measure the distance from the electromagnet and the trapdoor. And what do I find? I find the acceleration by using the equation of motion of acceleration. So delta x is equal to 1/280 squared plus v0t. But my v0, my velocity initial, is how much? It's 0 because I'm releasing it from rest, right? So then what would it be? It would be delta x is equal to 1/280 squared. You put the value of delta x, you put the value of the time, and you will get the value of acceleration, which is supposed to be 9.81 meters per second squared. An amazing experiment. I love it. It's very nice. We'll move on to question number 24. A boy is standing near the edge of a rooftop. Using a slingshot, he shoots a pebble from a point located 45 meters above the ground level. The pebble leaves the slingshot with an initial velocity v0 of 24 meters per second, directed almost vertically upward. It moves up to reach its highest point and goes all the way down to the ground, barely missing the rooftop. The figure below illustrates the situation: neglect, friction, blah blah blah. Determine with respect to ground level the maximum height reached by the pebble and calculate the time that it takes to reach that point. Okay, now honestly speaking, we can use the trajectory equations you remember from chapter 2, but because I'm doing this video later than chapter 2, we're gonna imagine that we don't know anything about trajectory equation. If it came in the computer part, use the trajectory equation. To find h max, you're gonna do v0 squared sine theta over blah blah blah. Here in this scenario, theta is gonna be 90 because it's thrown vertically upwards, okay? So anyways, we will imagine that we don't know any of this, okay? Because if this comes in the written part, for example, and they ask us to solve it using equations of motion and not trajectory equations, then we cannot use v0, we cannot use that, okay? Now, first thing, what do I know? I know my velocity 0 is upwards. That means it's positive, right? That means my acceleration is gonna be negative. That means it's gonna be minus 10 meters per second squared, okay? Now, V final is gonna be equal to what? It's gonna be equal to acceleration times time plus v initial. So my v final, it's gonna be equal to my acceleration, which is minus 10, times my time plus my v initial, which is how much? Which they gave it to be, which they gave it to me to be 24 meters per second. Okay, now how do we reach delta y? What's delta y? Delta y is the highest point, okay? Delta y is equal to 1 over 2 acceleration times time squared plus v0t. So minus 10 times half, that's minus 5t squared plus 24t. This is delta y. Another equation we can use for delta y is 2 times acceleration times delta y is equal to v final squared minus v initial squared. That means, how much is v final? V final, okay, so basically v final squared, what we can write as v final squared minus 24 squared is equal to what? Is equal to 2 times acceleration, which is minus 10 times delta y, so minus 20 delta y. And basically by using the regular equations, we got what? We got some equations that are going to make our life easier. So now determine the maximum height. Maximum height at the top, v is going to be equal to what? It's going to be equal to 0. Very important information. If v is equal to 0, how much will delta y be equal to? Which equation do I have? Velocity final, velocity initial, because this is velocity final. Which equation do I have? Velocity final, velocity initial, acceleration, and delta y, because I need delta y, the maximum height. So this equation, I'm going to be using it. V final squared minus v initial squared equal minus 20 times delta y. So delta y is equal to minus 24 squared. How much is that? Minus 576 over minus 20. So I will get delta y to be how much? To be 28.8. Now this is not like the maximum height with respect to the ground. This is delta y. So from here till here. How do I find the maximum height with respect to the ground? I need to add the height of the building. How much is the height of the building? 45 meters. So 28.8 plus 45, which will give me my answer, which is 73.8 meters. Okay, this is here, 73.8 meters. Now what do they want me to find? They want me to find the time it took to reach that point. I know that delta y was how much? Delta y was 28.8. Where can I substitute this? I can substitute this here. 28.8 is equal to minus 5t squared plus 24t. So I can move this to the other side and make it equal to 0. I will now use 0 is equal to minus 5t squared plus 24t minus 28.8. So mod 5, 3 minus 5, 24 minus 28.8. This will give me one answer, which is how much? Which is 2.4 seconds. Okay. So that is the answer for the time it took to reach the maximum height. Oh my goodness, no, I don't want to lose the equations. Okay, how am I gonna do this? Okay, so I'm just gonna get rid of this. There we go. Okay, so I'm gonna rewrite the equations now. Acceleration is minus 10 meter per second squared. V final equal minus 10t plus 24. Delta y equal minus 5t squared plus 24t. V final squared minus v initial squared, which was 24 squared, is equal to minus 20 times delta y. Part B, what does it say in part B? In part B, it says, what does it say? Find the time when the pebble passes by the initial position. Okay, here in trajectory equation, you can use t ground and you'll get your answer in 5 seconds. But from here till here, how much would my delta y be? My delta y would be how much? It would be equal to 0. So what I could do is I could take this equation, delta y equal blah blah blah. I can make delta y 0. So 0 equal minus 5t squared plus 24t. I solve it. I do mod 5, 3 minus 5t squared, 24t, 0. I would get two answers, my bad, which is 4.8 seconds and 0 seconds. Which one do you think the 0 seconds is for? Why do we have 2 times, first of all? We have 1 time for this point over here, which is 0 seconds, and 1 time for this point over here, which is how much? Which is 4.8 seconds. Now, what's another thing we can know about? We can find their final velocity. At 0 seconds, what would be my final velocity? V final would be equal to minus 10 times 0 plus 24. So V final would be 24 meters per second. If I substituted instead of 24, 4.8, so minus 10 times 4.8 plus 24, I would get minus 24 meter per second. So it's the same magnitude of velocity, but it's going in opposite directions. One's going upwards, the other one is going how much? It's going downwards. Okay, that's it for part B. We'll move on to part C. What does it say? It said find the instance when the pebble is 10 meters above the shooting point. Okay, and then 10 meters below it. Okay, what does it mean 10 meters above? That means this is my initial point, 0. We need these 2 points over here. Why? Because it will be 10 meters here and 10 meters here, right? So what can I do? I can take this equation and substitute delta y as 10. Delta y equal minus 5t squared plus 24t. I move 10 to the other side. Minus 5t squared plus 24t minus 10. So it will be mod 5, 3, minus 5, 24, minus 10. I will get 2 answers. The first time is 4.34 seconds. And my second time is 0.461 seconds, okay? So this is for above, you know? So 10 meters above, now 10 meters below. How much would, what did I erase these, sorry. How much would my delta y be now? Delta y equal minus 5t squared plus 24t minus 10. My delta y would be below, that means my delta y would be minus 10 meters, right? Okay? Delta y equal minus 5t squared plus 24t. Delta y is minus 10. So I'll move it to the other side. It will become plus 10. So mod 5, 3, minus 5, 24, and 10. So I will get 2 times. The first time is positive 5.19 seconds. My second time is a negative second. Can we have negative times? No. That means this is my only time for it. So I have only 3 times, which is 5.19, 0.461, and 4.34. Now, part D, what does it say? It says find the speed of the pebble as it hits the ground and calculate the time it gets to take there. So they want to find the speed v as we reach the ground. Okay, what equation will I use? I have v final. I have v initial, which is 24. I have delta x. What is this? Delta x. How much is this delta x? It's minus 45 meters because delta x is negative the height, right? Okay, so then what will I be able to find? I'll be able to find v final squared by this equation. V final squared minus 24 squared is equal to minus 20 times delta y, which is minus 45. V final squared is equal to minus 20 times minus 45, that's 900. So 900 plus how much? Plus 24 squared, how much is that? 576. 900 plus 576, that's v final squared is equal to 1476. How do I find v final then? I do radical, and radical, right? So radical 1476, I will get 38.41, right? This is my answer. Now, for this one, I could have either positive or minus, because remember, if you do the roots, you'll get plus, minus, what? 38, what was the answer? 38.4 plus minus 38.4 meters per second. Now, find the time it takes to get there. So now this is gonna help me. I have my velocity final. I can substitute it in this equation over here. And once I substitute it in this equation, I will see, is it positive acceleration or is it a negative acceleration? So, I have plus minus 38.4, right? I will take plus 38.4 is equal to minus 10t plus 24, and then minus 38.4 is equal to minus 10t plus 24. I move this to the other side. 38.4 minus 24, that's going to be 14.4. 14.4 is equal to minus 10t. Time would be 14.4 divided by minus 10, which is minus 1.44. Again, I open this, sorry. 1.44. So can we have time to be negative? No, so directly you cross this out. That means this would give me my answer. I'll move 24 to the other side. So minus 38.4 minus 24 will give me minus 62.4. Minus 62.4 equal minus 10t. T is going to be equal to 6.24 seconds. So this is a positive answer, and time can only be positive because it's a scalar quantity. That means what? That means my answer is what? 6.24 seconds, and my velocity is how much? It is negative. Perfect. That's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful